retire as early as possible, they need to double their money. Double the money. So we're going to start with an investment of how much? Do I know? That's time. Yeah, we're starting with $1,000. And if we need to double the investment, where do we need to get to? 2,000. And lucky, they tell us that. So how long did it take us to double our money here in this account? 6.9 years. Fantastic. So accounts Z takes 6.9 years. We are already very close to being done on this one. Now all we need to do is figure out account X. Again, it's paying 5%, and it's paying 6% for account Y. So those are the only changes that we need to make. There's one other thing that you can see here. They started adding in these new words, compounded continuously, compounded quarterly. Why don't we, since we haven't seen those before, let's circle continuously. That's going to be important. Let's circle quarterly. For sure, that's going to be important. Now, what I want you to do is take this entire top page, the whole top page, everything, and just gently tear it off. Now, on the back, you're going to see your foldable. Please fold this into thirds. And we're going to have a nice little chart to help us out through today's lesson. To help us through some of these loans that we're going to have to take. Or maybe some of the savings accounts that we're going to open. Alrighty. And here we go. We have all three different types of accounts. We have the monthly numbers. And you'll want to label this one Game of Life, right? This is the one that we've been working on all week. Game of Life. Okay. We were using the formula (1 plus r to the n) over 1 plus r to the n minus 1, right? This was the formula we've been using over and over, and this is the very last thing we did on that quiz before we got out of here for spring break. So this is kind of touching on what we just finished. And then you want to remember that this this number here, this r, interest rate, was where we took the decimal and divided by 12, right? Like we physically put it into months to make this work out. And this n was also in months. So if they told us like 5 years, we'd have to multiply it by 12 to get 60 for that n. Okay? This is where we just came from. And again, they told us on our graph here, this is going to be our account Z. So it took 6.9 years to get to 2,000. It's almost going to take 7 years to double our money. Now, over there on the side table, I can't actually see y'all, but are we okay so far on column 1? Yeah? Okay. All right, so we've caught up on column 1. Now let's look at column 2. And column 2 is going to give us any numbers compounding. So they can tell us that we want to compound it quarterly. How many quarters are in a dollar? 4, and that's why we have it here. They could tell us we're semi-annual, which is 2, right? Twice in a year. They could tell us it's annual, which is 1 time a year. They could even tell us to compound it monthly. If they told me to compound it monthly, what would I put there? 12, right? There are 12 months in a year, just like there are 4 quarters in a year. Okay? So no matter what they tell you, you're going to be able to use this formula where P is your starting value, and then you have 1 plus R divided by N to the NT. So this n over here, let's say that, just quick example off to the side. Let's say that you wanted to compound quarterly. Let's say on a 5% loan. When you compound something quarterly, what does that mean this n is going to be? What number will it take on? Yeah, Jackie? If we compound something quarterly, what is n? 4, because there are 4 quarters in 1 year. And that means up here at the top, we're going to have 4 times this variable, 14. Is that okay so far? So what would my denominator down here be if I told you to compound it monthly, Erica? 12, right? So that's how you can easily identify and spot this is quarter compounding. And it will look exactly like that on the answer. Okay? Just like this. There's continuous compounding, which is even more fun. So simple interest is easy, right? I give you a $1,000 loan. I charge you 3%, right? That means that you're going to owe me just that set amount of interest, and that's it. You're done. But if I take the number, the loan, and I compound it quarterly, that means that after a few months, I'm going to take some interest. And then, because my pie is growing, when I take the next interest, it's going to be on a bigger amount, right? And a bigger amount, and a bigger amount. And so you're continuously compounding. And that equation starts your initial value, whatever you take a loan out for in the beginning, or multiplied by the variable e, and then raised to the RT. Perfect. PE to the RT. All right. Now this E is an actual letter on your calculator, and I'm going to show you where that comes from. This E actually comes from what's inside of this grouping. These are essentially the same. This is just a series, and throughout this unit, we're going to explore how we come from this 1 plus r over n, how it turns into E over time when we continuously compound it. That's what we're going to explore this unit. Okay. For now, let's just get the numbers in like we did over here, right? Let's actually just substitute in. Tell me, what would this P equal? What does it stand for in the first place? What do you think, Chris? What does P stand for? What word could that symbolize? Profit. Good guess. Good guess. What's it called when you make an initial investment? What's that initial amount called? Miss Crouch is the. It's called the principal. Very good. And so that's what this P is all about. It's the principal. So from here, we're going to say that we started with how much in this little example? Yeah, 1,000. Good. So A equals 1,000. Now they tell us that this is a, let's see here, a 6% loan, and it's compounded quarterly. 6% loan, compounded quarterly. So I'm going to say 1 plus, what's my numerator here going to be, Andres, on a 6% loan? 0.06, and what's my denominator going to be, Soto? 4, because we are compounding it quarterly. Good. And then up here at the top, 14. Cool. That's going to be our second type of account that we could put our client into. And we only have one more, right? So this is our continuous compounding. Again, what was our principal amount, Annie? 1,000 times the variable E. And then we're going to raise that to the RT. So we need to know the interest rate of this one. The interest rate is 5%. So what's that 5% going to be as a decimal? Yeah, perfect. 0.05 times t. That's it. So all we need to do for these, to be able to solve it out is look at a picture. I think is going to be the easiest thing. All right, so let's look then on our calculator. See if we can answer these questions. All right, so go to your home screen, get into a new document, and don't save anything, just go to a graph. We're going to do the middle column, and then we'll do the very last column, like that. So our first middle column here was 1,000. I would highly recommend that you type the parentheses that I'm typing so that it makes sure that it comes out right. 1,000 times, and then we're going to put in the 1 plus 0.06 divided by 4. And then you're going to raise that to the 4x power. So again, we're working on the equation that is in the very center column. And this is exactly how you do it on the STAR test. Remember, you can use the calculator for every single problem on the STAR test. Okay? There's not a portion of the STAR test where you wouldn't be able to have access to this calculator. And that's why they're almost all word problems. They're almost all like this, where you're going to take 4 or 5 steps for each of them. All right. Once you get this on here like that, you want to hit the enter button. This is actually one of the state of Texas things. We have to make sure that everybody can get to this because we're starting to do technology kind of thing. Remember, Chapter 6 was all exponents, and Chapter 7 is when we make the calculator do all the exponents. So we're going to do a lot of calculator work. We all good so far on this stuff? Right. Hit enter, and then of course nothing comes up, right? Because our minimum deposit amount was 1,000, and right now our dollars go up to 6. So we need to fix that. Here's an easy way. Go to Menu, Window Zoom, and then Zoom Fit. Should be able to see your curve now, and that's a really pretty curve. You can see right here, it comes right through the 1,000. That's your initial investment, that 1,000, and we're just looking for our money to double, right? So how long is it going to take for our money to double? What's double 1,000? 2,000. We're trying to get to 2,000, right? Is 2,000, is that on my x-axis? Is 2,000 on my y-axis? Which one? Y. So let's do that. Let's add in a line in F2 that says y equals 2,000. Now, some of you won't have the right window, right? Because if you look at the very top, it goes to like 1940 or something. Remember, we're looking for 2,000. So change your window or drag your graph down so that you can actually see the intersection point. This is where your profit curve is going to intersect the goal. The goal is to double your money at 2,000. Cool. So walk me through, how would I find this intersection on my calculator? Carla? Perfect. Menu, Analyze Graph, Intersection. Now just click to the left and the right, and that's the answer. So let's go ahead and write that one down. On our second column, we know that it's going to give us 11.6 comma 2,000. And now let's work on interpreting this coordinate point. Brian, what does this actually mean? The 11.6. What does that even mean? True. So give me a sentence that tells me that's what it means. state final, Brian, just in the back. You got that. Okay? 11.6 years to double our money. So, are we okay in account Z or in account Y? Which one's better? Z, right? Because it only takes 6-something years, 6.9 years for me to double my money. But here, it's going to take me 11.6 years to double my money. All right? So, on the front, now we know that. It's going to say 11.6. And now what we have is this very last one. And that's what's going to happen right now at your tables with your calculators. Now that you know how to do this once, I want you to do it again. Tell me how many years it takes, and then answer the question, which account should you recommend to the client y por qué? Okay? All right, we'll take 3 minutes on that to get your equation in the graph. And then find that intersection, please. All right, a few more seconds to get that intersection point. All right, guys. Last few seconds. Wrap up where you're at. All right, let's take a look at what we got. So we put in this equation into the calculator. And we get to take out all of this stuff. We don't need any of that. in our equation. There we go. We can take all this out, right, and replace it down here with the letter E. And then at the top, we want to have 0.05x. When we do that, we can take out, I guess, all this other extra stuff we don't need. And now we've got our equation. And when we don't move anything, if you don't touch anything, it will continue to recalculate that intersection point for you. You don't have to go through the whole song and dance again. Okay? So this is another way to get going really fast. So now your new answer is 13.9. And then, Ricky, if you'll help us interpret that coordinate point, what does this actually mean for us today?
13 years. You're gonna have, I think it's 2,000. Is it 2,000? Yeah, right. 2E.
Awesome. So what Ricky said is in 13.9 years, we should have $2,000. So let's go ahead and write that information down on the front. In 13.9 years, like that. And so now we're all good. We got 13.9, 11.6, and 6.9. With all of this information, Casey, what would you recommend for your client? Which type of account? Account Z, for sure. And it's because it has, it's only going to take 7 years to double my money. This one is almost 14 years. That's double the amount of time for my money to grow. So this is not going to be a good one, and this one isn't going to be a good one either. I want to go with this one. All right. So again, this right here, best friend for this unit. We're going to hang on to this foldable, put it off to the side. And I want you to now look at our do first. 3 minutes on this one with a partner. Take what you just figured out, please, with your foldable, and apply these equations now to what you're seeing on the foldable to this right here. One for medical and one for banking on 1 and 2. If you want to talk, collaborate, if you want to get together to figure out what these kinds of equations are, what they're doing. I think a lot of you have probably already started to figure out the secret behind this. It's not necessarily slogging through all the problems in the math. It's actually looking at the answer. about 10 more seconds here. Some of you went through this in a calculator way. Bravo. Some of you went through this the logic way. Also, bravo. And then here in a second, we're going to talk about a few test-taking strategies here. I lifted these directly off of some of the quizzes, tests, and a star, and just changed the numbers for you. Look at the scenario. In a lab, 140 cells are going to start the experiment. The number of cells increases. So, are we growing or are we decaying here? Yeah, we're growing here. So we need a formula that will show growth. Let's look at part A. Part A shows 0.87 to the t. 0.87, is this a whole or a fraction? Yeah, 0.87 is a fraction. So what would happen if you took a fraction, maybe like 1/2, and you raised it to the t power? In other words, you squared it. 1/2 squared. Are we getting bigger or smaller? Smaller, right? Because 1/2 times 1/2 is 1/4. So we went from 1/2 to 1/4 when we squared it. Are we getting bigger or smaller? Smaller. And that happened right here. 0.87 to the t. You need to make sure you know the logic behind what I'm saying. Because this is smaller than 1, and you raise it to a power, it's going to give you something that is smaller. When you square a fraction, it will give you the smaller. Okay? So part A is decay. No good. We don't want our cells to die in the petri dish. They need to live. All right, now let's take a look at this one. We have 140 times 1.13. Okay, well that seems about right. We have 140 because we started with 140 cells. We have 0.13, which is 13%. That seems pretty good. This seems like a growth thing. But let's think about this. In any of our loans, any of our loans, did we ever raise the principal to the power? That was never a part of the deal, right? Because we don't want to be paying $3 billion for a $30 loan. Like, there's no way that we're going to raise the initial amount to a power, right? No good. So this one is also not possible. Let's take a look at C. Why could you say that C was not going to work out for you, Karen? Okay. Well, yeah, because did they get the 140 right? Yes. We started with 140 cells. That's good. Now, we see the 13% here, too, right? Ish, kind of. 0.13, is that a whole or a fraction? Fraction. So, what's going to happen when I take a fraction to a power? Is it going to get bigger or smaller here? Smaller. So, is this my one? No, because my cells are going to be dying. Good, Karen. So, this is a no-go for us. Just by logic, we know that it's going to be this one, but let's make sure that we know why. Right? Because we're looking at here, this is basically PE to the RT, right? Because cells are dividing continuously. They are continuously compounding. So it makes sense that we're going to have a growth factor here, right? This is a whole bigger than 1. We're going to square it so that number is getting bigger, and then we're going to multiply it by 140. All of the above, right, say that this is a growth formula. Okay? This was the only one that is a growth. And you need to know that part of the logic so that you don't actually have to do the math problem. You can just skip straight to it. Okay? Wow. So we put answer D for that one. Let's go on to the next one. It says Rick is investing 850 euros into a certificate of deposit. All right, so who knows what a certificate of deposit is, or a CDE at a bank? Good. It doesn't matter. You don't have to know. They're gonna give you a product on the STAR test that you don't know what it is. They're also probably going to give you a currency, euros, yen, yuan, rubles, whatever. They're going to give you a currency you're not familiar with just to try to trip you up. Again, you don't need any of that. If you got lost here, you're going to get this wrong. But if you ignore most of this, you can just look for the correct formula. They tell us that this one is compounded monthly. So go look back at your compounding, any compounding, that the middle formula. We are compounding monthly, so what number should you be looking for? Monthly. 12. What is the only one that has that 12 in the fraction? G. That's it. That's it. And it makes sense because 12 times 3 years up here, 12 times 3 is 36. So that's why we have a 36 up here. That checks out. Anyways, this is a really quick way for me to get straight to the answer without having to go through all the stuff that I may not know, may confuse me, or may turn me off from the problem. I don't need any of it, as long as I know my formulas, okay? So we're going to keep this around a lot today to help you out. All right, with that in mind, I want you at your tables, please, to start a little bit of review practice for the final, and then also a few new things. Review stuff, remember, I just changed the letters on you. Remember from chapter 6, when we multiplied like bases, what shortcut could we take with our exponents? Yeah, multiplication matches with addition. So 6 plus 3 is 9. And again, if we were dividing, that's when we can do what with our exponents? Subtract. 6 minus 3 is 3, so this will be x to the third. So yeah, remember your rules here. Now I just changed the letters from x to e to help you get started. There's some division problems and a couple other kind of review deals. Remember, anytime you see graph, whenever they talk about graph, what should you do? What's the key point? Good, guys. It's a t-chart. So you already know that when x is 0, y is 1. If you know that, you should be able to work towards the correct answer down here because you know what should be true. Cool. I'm going to give you 10 minutes at your table for this. 1, 2, 3. And then on the back, 7, 8, 9, and 10. If nothing else, y'all need to get through 10, okay? So let's take a look. We've got e to the negative 2 and then e to the negative 9. What did you do here, Chris? So you got e to the negative 11. All right, Flores, is this e to the negative 11 happy? No. What can you do here? Put it as the denominator. Good. 1 over e to the 11. And now, all of a sudden, we went from a negative customer to a happy customer. We just had to switch what floor they were on. They were on the numerator, didn't like it. Not into it, not feeling it at all. But if we come down here, we're good to go. So that will be our final answer, C. Go on down here to the next one. We have 4 to the first power, e to the negative 3x power, and then we raise all of that to the 5th power. And I went ahead and wrote this in here specifically because we're going to get to use our special rules here. So we're going to do a power to a power, which means that we can multiply our exponents together. So this will be 4 to the 5th, e to the negative 15x. Where can I take it from here, Brian? What's 4 to the 5th power? Yeah, so we can at least do that. 1024. We know that part. That's good. E to the negative 15x. Happy or sad right now? Sad, because we've got the negative sign here. So how are we going to make it happy, Erica? What can we do? Put it in, instead of the bottom, it starts with the denominator. Good. E to the 15x. Now, because we're in the denominator, we're happy. And we can say that this is 1024 over e to the 15x. Fantastico. Number 3, remember we already actually did our t-chart here. So the work has been done for us. What we need to do is substitute in now a 0 for all of my x's. So let's do that. Let's put in a 0 for all of my x's. 0, 0, 0. Now hopefully one of these will give back y equals 1. So we'll see. All right, we have e to the 0.5 times 0. So this is actually just e to the 0 power. What's anything to the 0 power? It's not. Yeah, good call, good call. That was a really good correction. Anything to the 0 power is 1. So, and I like how like quickly we fix that. So this says y equals 5 times 1. So y equals 5. Does that match? Nope. It's not that one. Let's go on to the next one. It says e to the 0 power times 5. What's anything to the 0 power? Good fix. Good fix. What's anything to the 0 power?
1.
Thank you. So this says 5 times 1. Is that a match? Nope, because this is still 5. So it's not that one. Let's go on to these last two. They say y equals e to the 0.5 times 0 is 0. E to the 0.5 times 0 is 0. So these would both be 1. Yeah? E to the 0 power, e to the 0 power. So y equals 1, y equals 1. But here's the issue, though. Which one of these is going to give us this kind of, what would you call this? Downward decreasing? Yeah, decay. We need a decay here. Which one of these is going to give us a decay? Yeah, look at that. It's going to decrease every time. It's going to decrease. Because this negative exponent means that it's actually like that, right? So when you increase this number, x, 2, 3, 4, your denominator is getting bigger and bigger and bigger, which means the whole thing is getting smaller and smaller and smaller. Okay? Good deal on that one. Let's come on over to number 7. And look what they did. They asked us to take a graph again. So what should we be doing here? When you take a graph, you should do what? T-chart. T-chart, guys. So put out your x and your y. You need to only look at these two coordinate points, 0 and 1. Just pick easy ones for yourself. Very easy ones. All right, so we go over to our calculator. And on the calculator, we get into just a regular old calculator screen. And here's what we can do. We can type, you know what we should do? Is actually go to a graph. That would be better. Whoa, not that one. There we go. And we should type in the log of x. And you can put it in parentheses like that. And what we want to do is just look at this function to make sure we got it right. Wait a minute. It changed. It said log of x, but now there's this like 10 down here. What is that? Where is that? Ah. This is called the base. This is the base. So on your paper, make sure you're diagramming log base 10 of x. Log base 10 of x. So 10 is the base. What else has a base of 10? How many fingers you got? 10. When you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what happens? You start over. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then you start over. Our entire number system is base 10. It's all in groups of 10. Which is why we don't really type the 10. just like pops up. This is understood. That's how we count. We count by tens. Okay? So this is our normal parent function. It's how we always count. Something that you would change this number, time. Time, right? We do time. There are 60 minutes in an hour. So time is a totally different base, right? And that's why it can be hard sometimes for us to convert between like 10.5 hours. It's not 10.5 hours, right? It's different because they're in different things. Okay? And that's where all that comes from. Alrighty. So, given that that's the case, let's pull up our table. Control T here. And get us some values. Alrighty, so when we get to 0, it says, let's see here, undefined. So we're going to write undefined next to 0. Undefined. And then next to where x equals 1, we can write 0. And that's basically all we're going to need from this picture to pull out this t-chart. That's all we need. And we were going to sketch this little parent function real quick, just like that. You're going to take your coordinate point here. Here's that 1, 0 that's in the t-chart. That's this point right here. And then we know that as we get to 0, it's going to be undefined. So, in other words, we can't ever actually get to 0. We're going to get as close as we can, but we can't actually touch it. It's a limit, right? There's a limit to what this function can do. And what this function can't do is have an x value of 0, because it's undefined there. So all they ask us for is this right here, which is a super quick sketch. We just did a t-chart with 0 and 1 and sketched real quick. That's all they want. And then we need to do domain and range. Your range is the easy one, right? What's down here? What number is way down here on the y-axis? Negative infinity. And this arrow marking means that on the y-axis up here, what's your biggest number? Positive infinity. So range, all real numbers. Negative infinity to positive infinity. Good. Are we going to have any x values for 0? Right here? Are we going to have any x values? No. It's undefined. So we'll never have this function get to 0, especially not negative 1, certainly not negative 2 or anything over here. So yeah, x has to be bigger than, what number can it not be? 0. It can't be 0. There we go. All right. Now we're going to do one more thing. This is the very last thing that we need to do for this graph, and that's put a dotted line right here at x equals 0, right here. You want to write in the limit, right? This is the limit. Your graph can't go past this barrier unless you at all. This is the limit. And in this class, well, for this state test, they're going to call it something different. They will call it an asymptote. This is the third thing and our third key point for today, and that's our last one. Everything after this is practice. Asymptote. So we have continuously compounding, we've got quarterly compounding, and now we have asymptote. These are our 3 new things for today. And now we can use this new info to look at this one. Before you even get started, though, what kind of translation is this? Here's the parent function, right here. Here is the new function. What kind of translation has happened here? All right. Yari, help us out. When you look at the difference between your parent function, our new parent function for this chapter, and then this function right here, what's the big change? Okay. All right. So we see a 3 is different. Good. Very good. So now we change bases from 10 to 3. And then what's the other thing that you see that's different? Yeah, we went right 4 units. Good. And we know that we went right 4 units is because we're right here, right? This is an X movement. And instead of going left, we have to go right. That's it. That's all we got to do. So this right here, the only translation that's happened here is Andres. He said this is right 4 units. And I knew it was left and right because we're in the X grouping. And I have to do the opposite. So let's look again at our T-chart because we're going to make a graph. So we're going to take all of our x's and shift them right 4 units. So now x is 4, y will be the same, undefined. And 4 plus 1, now my x is 5, and my y should be the same, right, 0. So now we'll use this new T-chart to help us graph this new log function. We have 2 key points that we need to look at. We have 5, 0. And then it says 4 is where our limit is. So we're going to put our asymptote line right here. And then here's where our function, it can't go past that limit. It's going to come up through our x-intercept and then curve across. So all we need to do is change our domain of range to reflect right 4 units. So our domain, x has to be bigger than 4. The range, same. Negative infinity to positive infinity. All right, guys. We need to get into our last 2 questions here. And these are going to be very much like Mrs. Patricio's geometry class. We had to solve a couple of equations by actually just writing the words out, and that's how we did our translation. So that's what we need to do here. The first thing I want you to do is write this sort of y equals mx plus b format. See here it's backwards. So I want you to write this 0 equals log base 2 of 1. Just flip the order, and that's going to be so much easier. Okay? So now we're in the place where Ms. Patricio's knowledge from geometry kind of catches up with us, and we want to write out this information in word form. So this is going to say 0. Another word for your equal sign is log. All right. So here, logarithm. All right. So 0 is the exponent of 2 to get 1. Let's say that all right, so let's try out just an extra little friend here, just to make sure we got it. All right, using the pattern you just went through, if you would please go ahead and solve this out at your tables using just the same steps that we went through to get to your final answer here. I want to know if it's true or false. We did this okay? 2, sorry. Of course. All right, so let's have some help saying this one out. Casey, how would you say this first little piece here? That's true. Now, if I was going to write it, how would I write it? Perfect. So 2 is the exponent of, and then how do I finish this out, Annie? Yeah, perfect. 2 is the exponent of 10 to get 100. Perfect. All right, so Brian, help us set this up. How would you rewrite this now that we know what it says in human language? What would we write this as? True or false?
True.
Good deal. And so now what they're going to start doing to you guys is some of these numbers are going to turn into letters. And that's what we're going to solve. And this will turn now that you know this little trick, this will turn into like chapter 6 all over again for you. And you'll be able to say, oh yeah, if this 2 was actually an x, like that, that would make this an x, it would make this an x, and it would make this an x. Y'all think y'all can handle that? 10 to what power equals 100? Right? And that's chapter 6. So I'm just trying to give y'all some stair steps of how to translate between the machine language from chapter 7 and what we just did. This is something comfortable that we can all do because it's very Algebra 1. If we can just get it to this place, we're going to be okay. And the only way we can get it to that place is if we write it out. Once we get fast enough and much more practice at this, you're going to start doing it in your head, and logs in your head will be very, very easy. Become second nature. Okay? All right, so let's put all of these pieces now together. What does it all mean? Why did we actually go through all of this? Let's take a look. You invest $3,200 in an account. It earns 8% compounded continuously. Let's write a function for A in the amount of t years. All right, so part A1, what'd you get for that one?
8,400 times 1 to the plus 1 plus 1.8 minus 1 21.
Yeah. And we could just use our continuous compound formula, right? We use PE to the RT. If they tell us to continuously compound, we're going to use this formula right here. And so that's what we need to compound continuously. Yeah? All right. And it's just asking us, find the inverse of the function, describe what the inverse represents, all that good stuff. All right. Well, if we're going to figure out what the inverse represents, we should probably know what this represents right now, right? All right, so what is t standing for here? Swayze? What does the variable t stand for in this problem? Time in years, good. And what does a stand for? Yeah. All right, so if someone tells me this is how many years I have to save, I can tell them how much money they will have, right? Okay, that's what this equation means. And we want to make sure that you're very clear about that. As Despair says, it's polka dots or stripes. You need to be very, very clear about what each equation means. There's no wishy-washy. There's no middle ground. If you're getting tired, stand up. There is no middle ground. You need to know what the equation says now. Because we're about to start doing inverses. And it's going to get confusing if you don't know. This says that if someone gives me the amount of time they have to invest, I can tell them the account balance. Right? So I'm talking to a client, and they say, well, how much money would I have after 5 years? you put 5 in, you get an answer, right? No problem. We can pull that off a table, right? A T-chart, no problem. Hey, I've got 7 years to invest. How much money will I have? I've got 8 years to invest. How much? Like, it's annoying after a while, right? Like, what's the real question here? It's not about time. What is it? You want to know how much money you have. So that's a much easier question to ask the client, right? Hey, how much money would you feel comfortable with retiring on? That's a number that we can kind of look at. But if you think about that, if I put that number in here, how am I going to solve for t? Because that variable is buried in the problem. And that's what the inverse does for it. Because the inverse allows us to switch our x and our y. So if we do it this way, it's going to untangle the knot, and we'll be able to answer that question. We'll then be able to say, okay, you tell me an amount. Name a price. Name how much money you want, and I'll tell you how long it takes to get there. All right? So that's the difference between these two equations. The first one, I have to keep asking. After 5 years, how much will I have? After 6 years, how much will I have? After 7 years, how much will I have? Super annoying. Right? Flip the question. Hey, how much money do you want? And I will just tell you how long it's going to take. Okay? So that's the difference between our part A and part B. Let's find the inverse. All right. So we have A equals 3,200 times e to the 0.08t. And this is where we're going to start. Now, where we're going to end the problem, we'll say t equals, and then some big old long equation with a in there somewhere, right? That's where we're going to end. This is where we're starting. So we got a little bit of work to do. 2 things to help you on your journey. Thing number 1, this equation is going to get ugly. Expect that. Thing number 2, it doesn't matter. It's all going in your calculator. It's going to do all the heavy lifting. It can get as ugly as you want. You're just going to typey and push enter. Okay? So don't worry about that. I'm going to have to solve for this variable all the way up here. But I can tell that this variable is being multiplied by 3,200. So how can I get started? What can I do first? Yeah, I can divide by 3,200. So now I have a over 3,200 equals e to the 0.08t. I know, I asked y'all, I told y'all I was going to have y'all do this a lot. What does log mean in English? What does log mean in English?
The exponent of.
The exponent of. So y'all see right now what I'm trying to do is solve for the exponent of e, yes? All right, so what I'm about to do is I'm going to take the log of both sides, because what I want is not this e. I want to take all that junk away and just leave the 0.08t. Wouldn't that be nice, just to be able to solve it like that? That's what we're going to do. That's why we use logs. Because it's the exponent of is what we're referring to when we do that. So I'm going to take, my base here is e, right? Are we all on board with that? My base and my exponent here? All right. So let's take the log of both sides. Here's the log in base e. And if I do it on this side, I know I got to keep it in balance. I got to do it on the other side. So I'm going to take the log in base e over here too. Remember, it can get as ugly as you want, because you're just going to throw it in the calculator, and the calculator is going to do everything. That's what log is. It's machine language. So it doesn't matter if it makes sense to you. You just need to make sure that the right pieces are in the right place for now. And then we'll have the calculator calculate that. All right. Blah, 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 blah. Fun side point here for those of us back from chapter 6. Fun side point. Y'all remember when we had this, and we had to get rid of the square, right? Yeah, we took the square root, right? And then when we took the square root, this all canceled, yeah? So what do you think's going to happen over here? The same thing, right? Like, that's the whole point. We want all of this to fall away so that we just have the exponent. So that's what's going to happen. All of this extra is going to fall away, and we're just left with 0.08. Then we have one more step to solve and put it in the calculator. All right? So we have a log in base e of a over 3200 equals 0.08t. Because all of this other jazz gets to go away now. Now remember, I'm here, and I need to get here. So how would I take 0.08t and get it just to? What's my last step, Ricky?
Division. You gotta divide 0.08 on both sides.
Perfect. Divide 0.08 on both sides. And then we're good. So now I'm going to write my final answer right over here where it says t equals is going to be log in base e of a over 3200. And then we need to divide that by Ricky's 8/100. All right. They give us a clue in part C. They say they want the investment to double in 5 years. So what was the initial amount that I invested again? 3,200. What's double that? Right. So let's go back to advisor-client. Thank you for investing your 3,200 in Mr. Benning's highly legit operation. What amount are you looking for to get out of this investment? No, you're investing 3,200. You're investing 32. How much do you want out at the end? You want double, right? So what is double? 6,400. That's going to go in for A, yeah? All right, go ahead and do that. And remember, this is kind of pretty related to some of the other equations that we're going to see. These are going to get and that's okay because you just type it right into the calculator. Use lots of fun. All right. This one is ready for the calculator. Once we get the answer, that's going to be our t, and that will be it. All right. So on your calculator, you can just go to a straight up calculator if you'd like, which is totally fine. And you're going to type in the numerator first, so we can do log in base e. Uh-oh. It's not letting me put the e in the base. Are y'all having an e issue, base issue? Okay, let me teach you a shortcut. My E is not actually going to my base. If that happens to you, don't worry about it. Go here to the blue control button, and you see that E button. Push that, and it should say LN now. Are we good on that? Okay, LN, that's our shortcut version on the machine for log in base E. You don't have to type log base E if you don't want to. You can just push LN. Same thing. And then we gotta divide 6,400 divided by 3,200, which is, I guess, just 2. All right, so here's my numerator. Great looking numerator. And then I still need to divide by Ricky's 0.08. So I'm going to just hit the division sign, and then divide it by 0.08. And there we go. T equals 8.664. We'll pause here because you want to make sure that you're getting this one, particularly when it comes to the exit tickets. We want to go out a minimum of 3 decimals. Minimum. More is better on this. More decimals is better. Look at your neighbor. Work with your neighbor until you are able to get this. This is not going to go away. This is the foundation. Okay, we're all able to get to 8.66? Okay, so go back to your... Hopefully you've written that down. And now we need to interpret. Now that we have found an answer, we're looking at part C. It says, will you reach your goal? No. If not, how much more time is needed? We were planning on 5 years. Yeah, how many more years do you need? So you can say, no, I need 3.664, 3 decimal place, years more years, years more. Yellow is not strong today. Sorry. All right. All right. So that was kind of the pre-exit ticket, just to kind of get you a review where we're going to be today. I gave you some extra review in here. This is all going to be available online because I know that sometimes when we get through a lesson, we want to go back and just practice individual specific types of problems. So I left those in here for you. There's 7.2, and look at 7.2. They give you the continuous formula here, PE to the RT. 7.2 is all about E, all about the letter E. So what could you do here with E? Yeah, we can add these up. What would your final answer here be, Jennifer? Yeah, oh yeah. Yeah, perfect. E to the power of 3. Awesome. Over here, we have 25e squared, 35e to the 7. 25, what's another name for this position, this number? Starts with the letter C. It is a coefficient, and we can deal with our coefficients differently than our variables. So 25 and 35 is going to reduce to 5 over 7. I'm dividing my variables now. So what can I do with my exponents? Subtract. This is e to the negative 5. Is my variable happy? No, so it cannot stay in the numerator. It's got to come down here to the denominator. And so on, right? So lots of these types of examples on this page. Drop down to number 5 just for a second. Look at this. We're looking, is this a growth function or a decay function? On number 5. Why would you say decay? Yeah, the negative exponent is not happy.
Congrats to 6th grade for reaching the attendance goal for today. You have earned a Dean Pass for tomorrow. Congrats again.
All right, so look, I rewrote this function with a happy exponent now. And so you can see when x is 2, when x is 3, when x is 4, this denominator is going to get bigger and bigger and bigger and bigger. Will it ever get to 0? No, but it is going to continue to decrease like that. This is a decay, right? Because you're going to go from 1/4 to 1/8 to 1/16 to 1/64. The slice of the pie is getting smaller and smaller and smaller. It will never be 0, but it will always get smaller. What about part 6, growth or decay? Yeah. If you put in like a 2 for this x right here, that's e to the 8th power. And then you're going to multiply that by 0.7. That's a big number. And every time you increase x, this is going to get bigger. So growth, good. What about 7, growth or decay? So if x is 2 million, are we going to be bigger or smaller than 5? I don't know. You can always check on your calculator. But think about this. X is 4. So what is 1/4 of 4? 1, right? So now we have 5e to the first power. Now let's put in 40. What is 1/4 of 40? 10. So e to the 10 times 5, is that bigger or smaller? Of course it's bigger. Okay. If x, let's do a little chart. If x is 4, 1/4 of 4 is 1, right? And this means it's going to be 5 times e to the first power. So 5 times e. Now if we put in 40 here for x, we said that 1/4 of this is going to be 10, right? So this is 5 times e to the power of 10. So which one's bigger? The second one, yeah? So are we growing or are we decaying? Good. The only way we knew that was a T-chart. I want to drive that key point home. If you don't have a T-chart, this test is going to be bad. Have to T-chart the graphs. All right? Okay, over here, growth or decay? Decay, right? Because you can see this negative exponent is going to push you in the denominator. So it's going to be 0.8 on the top, and then e to the 3x on the bottom. So as x goes bigger, 4, 40, 400, 4 million, this denominator is going to get gigantic. 0.8 is going to stay the same. Right? So the slice of your pie is getting smaller and smaller and smaller and smaller and smaller. So this has to be decay. We might need a little bit more practice on this, yeah? Okay. Also, next page has 7.3 practice, because we did go through logs today too. So writing out the logs, the exponent of, with the equal signs, all that stuff, that is foundational practice. And if that didn't click with you today, that's fine, but you got to do this over the homework. Well, we got 5 minutes, guys. I don't know what you're doing. Chill. All right. Back page. This is the true homework assignment. This is what is due the next time that we come in. And also, your pre-exit ticket. This guy is a potential exit ticket for you. It's going to be key A. When you take the real one, the next time you come in, it'll be key B, C, D, or E, okay? You won't have A again. But I am going to use these problems and change up the numbers. So you need to know this specifically. All right, now we went through these problems earlier today on our pre-exit ticket. If you look back, you're going to see very, very similar problems, yeah? Same. So I want you to go through those and make sure that those are in your bank. Again, those little tiny practice problems in 7.3 and 7.2, if you get stuck on this stuff, that's where you need to go. Go back to the basics. Go back to the foundations. Relearn the foundation basics. Then come back here and get your practice, okay? This is going to come back on Wednesday. Is this when we're going to teach? each other. All right. Let's take a look at number 1. Okay, we want to rewrite the equation in exponential form. So basically what they're asking you to do is go from chapter 7, which is what we're learning now, and go and write it in a way that you saw it in chapter 6. All right? So this is saying 0 is the exponent of 9 to get 1. 0 equals log 9 of 1. 0 is the exponent of 9 to get 1. So when you go to write this now in your chapter 6 form, you're going to read this new sentence that you created. And you're going to say 0 is the exponent of 9. Great. So 0 is 9's exponent. And it's going to get us, in other words, it's going to equal 1. And now our whole job is to just make sure, is this true? Anything to the 0 power is? 1. Perfect, perfect, perfect. Try out number 2 real quick. We're going to check that, and then we'll stack our chairs for the day. All right, Sesame, how do you say number 2 in English and Cuban language? Guys, I can't even hear Brian. He's actually helping us out with our homework right now. Grab your seats. Chill out. Brian, help us out. 3 is what? Good. 3 is the exponent of 6 to get 216. And then you just check it. 6 to the 3rd power is 216. All right, guys, put your notes where they need to go. Course cards should be in front of you right now. Stack your chairs. And this homework packet will be due back on Wednesday. All right, see ya. Have a good one. And check your YouTube if you're having questions. This will be posted, this whole lesson.